Good afternoon, sir.
Good afternoon. Good afternoon. People who can, if you can keep your cameras on, I'll be glad. Only Chinmay and Parth switch on their cameras. Last class also I have seen. And both their wallpapers are very attractive. एक ने लाइब्रेरी लगा के रखा है, दूसरे ने गैलेक्सी लगा के रखा है। मेरे लिए ऑप्शन है ही नहीं, व्हाइट बोर्ड। Atomic structure. Okay. Fine. I yesterday sent you people magnetism का question bank. भेजा कि नहीं?
Yes, sir.
Why is there a mass bunk today? भाई दूज के लिए?
दिवाली
दिवाली तो कल हो गया भैया। यार but today we will be starting EMI. That's very important.
It seems all in a festive mood.
Festive mood, I can understand. Everything is okay, but EMI will be starting today. They cannot afford to miss that. So it's only 12. Let's see. Wait for 1 or 2 minutes. Okay, people are joining. Good grace. Now listen. If you people have observed carefully, there are quite a few things that we have covered till now which are only informations for the sake of information. Very carefully analyze what you learned till now. Force on a charged particle due to a magnetic field. You said Q into V cross B. Did you derive it? No, it was experimentally observed. Force on a current carrying wire I into L cross B. Did you derive it? No, it was experimentally observed. You derived it from Q into V cross B. Added up all those forces, you got I into L cross B. right? Force between two parallel current carrying wires. From I into L cross B, you derived it. So that was also practically observation. You observed one thing and you derived it in different form. That's our law. कोई proof है आपके पास? Experimental observation. You have not given justification for anything that you have done in magnetism till now, including the two contradictions. With a spring, the rod moving up. At times, Newton's laws appear to fail. So you have dumped us with lot of information in magnetism. Justifications are to come. It will come in this chapter. Right? That is why this chapter becomes important. It explains so many things which are given as information in magnetism. This is EMI. Full form of EMI.
Electromagnetic induction.
Electromagnetic induction. And this chapter is very beautiful. The theory of the chapter is only first 10 minutes. Uske baad application of this chapter will continue for long. Right? Only HCV has got 97 problems. In this chapter, only HCV has got 97 problems. I hope you understand how huge the application is. Firstly, we define a quantity called magnetic flux. Magnetic flux B dot E, exactly the way you defined electrostatic flux. Weber Tesla meters. 1 Weber is 1 Tesla meters. Right? Did I ever tell you the story of Weber and Einstein?
No, sir.
Weber was Einstein's guide. There are two ways of doing MS. MS by research and MS by academics. MS by research, the guide will give you a problem, you work on the problem, resolve the problem, find the answer. It becomes MS by research. The other is MS by academics. You study a textbook, you answer questions. This is academic. Right? Einstein had a very bad reputation with his guide. Weber's recommendations on Einstein were hopelessly bad. After his post-graduation MS by research, Einstein applied for job at 4 universities. All 4 rejected his job, his candidate. Then he applied for assistant professor post and not a professor's post. All 4 universities rejected. So on a sequence, Einstein was getting rejected. Who was getting rejected?
Einstein.
Of all Einstein, whose name is synonymous to physics now. If any layman has to speak about physics, Einstein ka photo laga de. Of all Einstein, he did not get a job in any of the top 4 universities. Forget about top 4, the sequentially lower universities also started rejecting him. Those were the times when the world was at war, World War II. Nazi rule in Germany. The world was in a very disturbed state, and Einstein did not have a very comfortable home to stay with. He was staying with his mom. Listen to this story, you will be amused. Wait, somebody is calling. Sorry. So where was I?
Einstein got rejected.
So Einstein was in need of a job. He was supposed to get married to his girlfriend and his mom is not giving him permission. And he is financially dependent on his mother. His parents were not living together. It is said Einstein writes a letter to his dad in which he showed suicidal symptoms. Of all, who? Einstein. He writes to his dad, if God gave me a choice, I wouldn't have been born. Right? His mom is not giving permission for him to marry his girlfriend and he's financially dependent on his mom. That was when. This is a critical point in the story. Listen carefully. It applies to each one of us. His friend tells him, there is one job which is a clerical job, not a teaching or a scientific or a research job, but it is in the patent office. It is a clerical job. Look at the irony. Every graduate in science was moving ahead in life. So the clerk post was given to a commerce graduate who did not know the difference between biology, physics, chemistry. So when there is a paper which comes for publication, the clerk needs to send it to the right person involving physics, chemistry, biology background, and the clerk from commerce background did not know. A chemistry ka paper hai ki physics ka paper hai, he used to not know. So they were in search of a science graduate and they were not getting for that post. Every science graduate was getting a better job except for
Einstein.
of all Einstein. Every science graduate was getting a better job. So his friend tells Einstein, look, I can help you out with a job. They are in need of a science graduate. But Einstein was a postgraduate. Graduate tak nahi mil raha hai. Einstein was a postgraduate by research. That too who worked under then the biggest names. And of all who? Einstein. So Einstein accepts the job just because he needs to come out of his mom's home and get married to his girlfriend. If not, his mom was not giving permission. Look at the irony. He joins the job in the year 2001, if I am right. Sorry, 1901. 1902, Lorentz sends his papers for publication, Lorentz transformations. It directly goes into the first person to receive them is Einstein. He goes through them and he understands few things which nobody else understands. 1905, he gave birth to special theory of relativity and published it in the journal Nature, then the best journal, even till date. Nature mein publication implies it's like turning the world upside down. Names like Weber used to get a publication, nobody else. Whole of the world immediately woke up. Who is this guy called Einstein? 1905. They started searching. They realized that he applied for a job in their universities and they rejected that. You know why they rejected? When accepting a candidature, they used to send a letter to the guide. And Weber used to give hopelessly bad recommendation letters about Einstein. He used to write, the guy was hopelessly bad, knows nothing about things, always lost in a world of his own, not a group worker, ... Weber's recommendation letters were very bad. And so his candidature was getting rejected. Right. Look at the destiny. He was destined to sit at a place where Lorentz transformations had to come to him. From there, special theory of relativity was given birth to. People mistake that Einstein got his Nobel Prize for special theory of relativity. No, he got his Nobel Prize for photoelectric effect. E equal to mc square didn't fetch Einstein a Nobel Prize. He got his Nobel Prize for photoelectric effect. Right, there are quite a few misconceptions about Einstein. Right, he got his Nobel Prize for photoelectric effect and not E equal to mc square. Long after he became one of the most versatile speakers in the Science Congress. Whenever in a science symposium, the most versatile speaker was Einstein. Initially, he was considered to be dumb, sitting all alone, lost in a world of his own, so on and so forth, before he picked up his job from the patent office. So if somewhere down the lane we are made to sit in a chair which we don't deserve, do not be under the impression that you are dumb. There is some reason why we are sitting there. Everything in your life will have a reason which we may not realize then. Have patience, you will see the reasons unfolding itself. One among that episode is Einstein's episode. Now, Weber Tesla meter square, magnetic flux. Faraday, this is once again one more interesting story. Faraday was not a science student at all. Out of passion, he worked on it. He doesn't give any technical explanation for what he observes. What he observed, he summarized. He worked out of passion. Faraday was not a science graduate. Can you imagine that? All of electromagnetic induction is born from Faraday. Faraday's law. He experimentally observed that when a magnet either moves towards a loop or moves away from a loop, or the loop moves away or towards, or the loop rotates about, any one of them. Magnet moving towards, magnet moving away. Loop moving away, loop moving towards, or rotating about its axis. You do any one of them, there is induced EMF in the loop. Induced EMF in the loop. Now he was amused to see that. Then he experimentally set up step by step what is the change that's happening. He summarized this and he said, whenever the flux changes, there is an induced EMF in the loop. Listen to every word carefully. There are so many legalities involved in this chapter. Whenever there is a change in flux, there is induced EMF in the loop. Faraday's law says, whenever there is a change in flux linking a loop, induced EMF is established. Induced EMF is established. बड़ा सिंपल सा स्टेटमेंट है ना यार, emphasizing concentrate क्यों बोल रहे हो? Whenever there is a change in flux linking a loop, there is induced EMF. What did I say? Whenever there is a change in flux linking a loop, there is induced
EMF.
He never told you vice versa. He never told you vice versa is true. Whenever there is induced EMF, it will be only because of change in flux. ऐसा थोड़ी नहीं बोला. Will we come across those examples? We will. Then I'll remind you about this. But remember, whenever there is a change in flux linking a loop, there is induced EMF. And he summarized this: rate of change of flux is directly proportional to the EMF induced. Then he said E is d phi by dt. The correction it came by Lenz's law. Lenz's law gave the correction E is equal to minus d phi by dt. E is equal to minus d phi by dt. The negative sign was introduced by Lenz, and negative sign is a consequence of conservation of energy. Conservation of energy. Why is it a consequence of conservation of energy? I'll explain. Take it down, please.
That's it.
Done, sir.
Now listen, why should this minus d5 by dt be a law of consequence of conservation of energy? Now take a circular loop and a bar magnet, you push it and release it. Bar magnet, you push it and release it. The bar magnet keeps moving with uniform velocity because the bar magnet is on a smooth surface. Nobody is doing work. The bar magnet is given a velocity. The bar magnet is moving with uniform velocity. Till when the bar magnet is moving, there is induced EMF in the circular coil. Induced EMF implies I am producing current without doing work. Not
Yes.
possible. This will be
Then-
violation of conservation of energy. I take a bar magnet on a smooth surface, I push it and I release it. The bar magnet is moving with uniform velocity. There is no force on it. It will be moving with uniform velocity. Yes or no?
Yes.
Once it is moving, the flux linking the coil is changing. Flux is changing implies there is induced EMF. There is induced EMF implies there is current. I am producing current without doing any work. Nature doesn't like that. Nature tells me I have to do work. Why will I do work? Why will I do work? I will not. I will push the bar magnet and release it. Why should I do work?
Sir,
I will be forced to do work if the induced current opposes the incoming bar. I will be forced to do work if the induced current opposes the incoming bar magnet. So Lenz's law technically tells you, Lenz's law tells us that induced EMF always opposes the cause. Induced EMF will always be in such a direction, such that it opposes the cause. Incoming bar magnet should be opposed. For example, if this is a bar magnet, north pole and south pole, if this bar magnet is moving towards, then the induced current should be in such a way, such that it should show me a north pole. Induced current as seen by the bar magnet should be in anti-clockwise direction. Anti-clockwise direction, incoming bar magnet will be opposed. Incoming bar magnet is opposed. North pole, here I will have a north pole. So now I am forced to do work. That work will be converted into energy, which will be I square R. Look at the other side of the coin. Suppose this is a bar magnet which is moving away. Moving away should be opposed. How will the moving away be opposed? If the current is in clockwise direction. So induced current will always be in such a way, such that it opposes the cause. Here the cause is increasing magnetic flux. So it will produce a magnetic field in the opposite direction. Here the cause is decreasing magnetic flux. It will produce magnetic field in the same direction to oppose the decrease. Griffith's language, nature abhors change in flux. Nature abhors change in flux. Abhor, dictionary meaning is hate. Abhor, dictionary meaning is hate. Right? Nature hates change in flux. Nature doesn't hate flux. It hates change in flux. Whenever there is a change, nature opposes it. Keep the bar magnet at rest. Loop is happy, bar magnet is happy, no current, everything is fine. The moment you move it, induced EMF will come into picture to oppose the change. Induced EMF will come into the picture to oppose the change. Consider one more example. This is a current carrying wire. I'll do one thing. Take it down to here and do it separate.
So there will be an equal and opposite field to slow down the magnet.
Right. Either when it is going this way or this way. Here I have a north pole, so it will opposing the incoming magnet. Here I have a south pole, it will oppose the outgoing magnet.
So is there a proof of it? Like, why it will be equal in magnitude? Like
Equal in
magnitude, the field.
magnitude of what?
So an equal and opposite field is being produced.
No, equal and opposite field नहीं. कहीं पर नहीं. Induced EMF always opposes the cause. It will not be equal and opposite. The effect will not become zero. It opposes the cause. That's all.
Or some magnitude less than it.
Right. Can I rub the board?
Yes, sir.
Now observe this. This is a current carrying wire. I is increasing. I is increasing. What will be the direction of induced EMF here? Now observe this. I is increasing. Magnetic field inverse is increasing.
Yes.
In the current carrying wire, magnetic field inverse is increasing. Yes or no?
Yes. Yes.
The inward increasing magnetic field will contribute to increasing magnetic flux through this.
Yes.
That increase should be opposed. How will you oppose? If you have current in induced current in anti-clockwise direction, then this will produce a magnetic field in the outward direction, which will oppose the increasing magnetic field. I again repeat, have a look at it. This wire will have magnetic field perpendicular to the board inwards. This magnetic field is increasing. That means the magnetic flux through this loop is increasing. The increase should be opposed. How will you oppose? By producing magnetic field in? By producing magnetic field in the opposite direction. And to produce magnetic field in the opposite direction, current should be in
Opposite.
clockwise direction. Let's take one more example here. I is decreasing. I'll change the direction of current. Current in this direction is decreasing and I have a loop here. Now, because of this, the magnetic field here is in which direction?
Outwards. Outwards.
Perpendicularly outwards. And the perpendicularly outwards magnetic field is what is happening to it?
Decreasing.
How should I oppose the decrease?
Opposite. Inward.
Decrease oppose karna hai. Decrease.
Increasing.
Something is decreasing. How will I oppose the decrease? By producing magnetic field in the same direction.
Yes, sir.
Because of this, the magnetic field is perpendicularly out of the board. Agreed. And what is happening to the magnetic field? It is decreasing. How do I oppose a decrease? By producing magnetic field in the same direction.
Right, sir.
So if I should produce magnetic field in the same direction, the induced EMF must be, or induced current should be in anti-clockwise direction.
Done, sir.
basically, this is a bar magnet. Agreed? To separate them, I will have to slide and pull. I need to apply a lot of force. It's a strong bar magnet. Do you see that? There's no glue, it's a magnet. Right? If I take anything iron and I stick to it in classrooms, generally when I show, I stick it to the bench and then removing ke liye, you have to apply a lot of force. That good a magnet is. These are two hollow pipes. Do you see this is hollow? Are you able to see?
Yes, sir. Yes.
Both are hollow. One is aluminum, the other is steel. Neither of them is magnetic. I have shown to you how strong the magnet is. Right? In this case, there is no attraction between this and this. Either steel or aluminum. Agreed?
Yes, sir.
So if I drop it inside, it should fall with an acceleration equal to that of G. Acceleration due to gravity, because it doesn't attract. Fair enough? Till now I was dropping it in steel. Now I am dropping in aluminum.
It will take some time.
Steel, aluminum. There's no cheap trick involved. You can see this aluminum. Steel. You see the difference? There's no cheap trick involved. It's hollow inside. And it doesn't attract either of them. So there's something that we are dealing with. Now have a look at it. Aluminum, when I'm dropping, you mean to say there is induced EMF established opposing the cause. So induced EMF steel में भी establish होगा ना यार, होगा. तो फिर why are you not observing the EMF induced effect in steel? Resistivity of steel is 10 times greater than that of aluminum. Resistivity of steel is 10 times greater than that of aluminum. Greater the resistance, current will be lesser. Lesser the current, lesser the opposing force, the magnetic field produced will be negligible.
Yes, sir.
Second important point, will the 10 times difference make so much of a difference? ध्यान से देखिए. Area of the aluminum loop was slightly greater than the area of the steel loop. Yes or no?
Yes, sir.
Greater the area of the aluminum loop, greater the flux through the aluminum loop.
Yes, sir.
Greater the rate of change of flux. Greater the rate of change of flux, greater is the induced EMF, greater is the current. And hence opposing force is surplus to slow down the bar magnet. To get these two rods, I had to go around in Jogeshwari, right from on SV Road, Jogeshwari to say Andheri tak, all hardware shops are there. You will get aluminum, square pipes, square tubes, the one anodized aluminum which you use for windows. Circular you will not get at all places. Steel I got at one place, but not aluminum. Aluminum I had to walk down every alternate shop to search for this. Afternoon around 2 or 3 after the class I went there. This is again an interesting part. Listen carefully. The owner of the shop was not there, and there was a boy of some 8, 9, 10 or 11 years hoga uska. I asked him, I already purchased the steel rod of this length. I did the calculations. I first bought the bar mat. Now I want an aluminium pipe of this length. How can I show the comparison for students between the two when I get the same length? Finally, only in one shop I got this aluminium rod. That boy tells me, ये aluminium pipe, इतना सा pipe क्या करोगे? पूरा pipe लेना पड़ेगा. I told him, okay यार, मैं पूरा pipe का पैसा दे दूंगा, मगर मुझे काट के देना. He has the lathe machine. Lathe machine पता है आपको? Slices iron, chipping iron. He has the lathe machine. Now at home, even if I have got a carpenter saw, aluminium rod I cannot cut. I need a lathe machine for it. I told him, you have a lathe machine, you have to cut till here and give me. He asked me, what for do you need? Now how to explain to him? I told him, घर में fit करने के लिए नहीं यार, class में पढ़ाने के लिए. I drop the magnet, aluminium pipe में तुरंत गिर जाता है. I mean steel pipe में तुरंत गिर जाता है, aluminium pipe में गिरेगा, आराम से गिरेगा. He laughed at me. He asked, क्या बोल रहे हो? अंदर वो magnet डालने से वो attract थोड़ी कर रहा है. I told him, today ये सब चिंता क्यों करना है यार, मुझे देना है कि नहीं, काट के देना है, बस मुझे इतना ही लेंथ करना. तो उसने बोला पूरा पाइप का पैसा दोगे तो काट के दे दूंगा. मैंने बोला पूरा पाइप का पैसा दे दूंगा. So he cut, and he was very inquisitive to see that when I drop it in the aluminium pipe, it will fall very slowly. He said, मुझे डाल के दिखाओ. He was holding the pipe, and I dropped, and the magnet fell instantaneously with an acceleration of g. The way it fell in the steel rod, it fell in the aluminium rod. He laughed in one go. I remember him laughing even. ऐसा हंसा मेरा और देखकर कि I was surprised. For a moment I was shocked. Did I do the calculation wrong with the magnet, or did I take the resistivity of aluminium wrong? I was yet thinking. Mind was puzzled. For 30 seconds to 1 minute, I was also puzzled. I thought I went wrong with the calculations of this aluminium and steel rod. But then it stuck to me immediately. When he was cutting this, if you people observe, this is a very fine finish. You see this side?
Yes, sir.
When he cut this, he was a small kid, not very well versed, skilled worker, Thane. So you can see the shape is not perfect. But when he was cutting, sparks will be flying. Lathe machine for when you cut. Right? I asked him, garam hai kya aluminium rod? He said, both. He held it with a cloth. He took a cloth and he held and he kept and he cut. And he said, dal ke dikhao. It was dead hot. I told him, dip it in water. Ganda pani tha wahan. Ek tub mein. I told him, dip it in water. He dipped it in water and removed. Right? Then I told him, up pakdo. And I dropped the magnet, it slowed down. He was shocked. क्या हो गया? फिर से डालो. क्या हो गया? फिर से डालो. He started peeping inside. He said, अब डालो. I told him, okay, तुम ऊपर से देख के रहो. No, he was perplexed. 1 minute back, when I dropped the magnet, it fell instantaneously. Now, पानी में डाल के निकालने से वो magnet बड़ा slowly डाला. What happened 1 minute back? The aluminium rod was very hot. When it is very hot, resistance of a conductor increases. Resistance increases, it became as good as a steel rod. Resistance was much higher, so it became as good as a steel rod. Induced EMF to hai, but there was no current, no opposing force, and so the magnet fell freely. For 5 minutes he pestered me. Kya kiya aapne? No, how do I ask him? Kahan tak padhe ho aap? No, these guys are trained to say always that they're 18 years old. ये देखने से पता चल रहा है मुझे ये not be more than 11 years old. ये 18 साल का हूँ. तेरा 18 साल का तेल लाने तुम कहाँ तक पढ़े हो? How do I explain Faraday's law to him? 11वीं तक पढ़े हो क्या? He said नहीं. तो मैंने बोला तो समझ में नहीं आएगा. How do I explain Faraday's law to him in that you drop magnetic flux, all that doesn't make sense. I told him it's magic. तुम्हें समझ में नहीं आएगा, बस तेरा पैसा ले. He followed up for nearly 2 to 3 minutes with me. I told him नहीं यार छोड़ दो, तेरी समझ में नहीं आएगा. There's nothing I can do about it now. Right? When the rod was hot, it was dead hot when it was put on the lathe machine. If the magnet fell with an acceleration equal to that of gravity. This is direct application of Faraday's law and Lenz's law. Why doesn't it happen in a steel rod or a plastic rod? Because the resistivity is more and induced current will not get established. Clear?
So if you would have taken a very strong magnet, so you would have also got shocked because of induced current.
Obviously, if I'm standing, that way I'm standing on ground. Now, right now, without slippers. So, if the magnet strength is increased further, we'll get a shock. So, size of the magnet and area should be calculated in such a way such that the current is less than 2 to 3 amperes. 2 to 3 amperes से कम current से काम चलाना पड़ेगा. Right? All these calculations I did. But that kid, when he laughed, I thought I went wrong with my calculation. And for 30 seconds, you should see the happiness with which he was laughing. पूरा पाइप का पैसा भी ले देना पड़ेगा और आपको किसी काम का है नहीं. And his laugh had such a sarcasm that क्या पढ़ाते हो यार. Initially, I was telling him, नहीं यार पढ़ाता हूँ मुझे. I need that only this piece. I cannot take the whole pipe. But that was a good experience. Can I rub the board?
Yes, sir.
What if the current carrying wire was perpendicular to the board inwards? This is right. This is infinite long wire and the current is increasing. Could you tell me the direction of induced EMF or induced current in this board?
Clockwise.
Anti-clockwise or clockwise? Anti-clockwise or clockwise?
Anti-clockwise.
Anti-clockwise.
Anti-clockwise. You think also?
Current carrying wire will produce a magnetic field in the plane of the board. Area of the loop is perpendicular to the board. Flux is B dot A, BA cos 90, and it remains constant. Flux is zero is not my issue. That zero is a constant. Induced EMF is d by dt of constant will be zero. Don't tell me induced EMF is zero because the flux is zero. Induced EMF is zero because flux is constant. So induced EMF in this particular loop will be zero.
Even in the previous case, if current was constant, it would have been zero.
Naturally, when in the previous case, if current is constant, it will be zero.
Done, sir.
Faraday experimentally summarized a few results. He didn't tell us the reason why things are happening this way. He couldn't explain because he was not basically a scientist. This is basically motional EMF. Motional EMF. You have solved a problem in HCV based on Hall's effect, something close to that. This is a thin rod. moving with a velocity v. When the thin rod moves with a velocity v, positive charges accumulate here and negative charges accumulate here. Why? FBI, force will be in the upward direction. FBI, force will be in upward direction. So accumulation of positive charge here and negative charge here will continue till you reach a point where VQV is balanced by EQ. V is the velocity of the rod. V is moving, the rod is moving with the velocity V. BQV is the force on the positive charge upwards, and an electric field established will give me EQ. At this stage, when BQV is equal to EQ, further polarization will stop. Do you agree with that? This field is BV. Potential difference, or technically EMF across the rod, will be E into L. BLV will be the motional EMF established across the rod. This is what happens in the microscopic viewpoint. Rather, this is the reason why if I have a metallic strip like this and a thin rod moving with a velocity, according to Faraday, there was induced EMF in it because the magnetic flux linking the coil is changing. According to Faraday, there was induced EMF in this loop because the magnetic flux linking the coil is changing. Right? That is explained by motional EMF BLV. Now there is polarization of positive charge here and negative charge here, and hence there will be current. Faraday never understood the scientific reason as to why things are happening. All that he told us was, as this slider will move to the right, the area intercepted is increasing, magnetic field is increasing, magnetic flux is increasing, so there is induced EMF. Will both the calculations give me the same result? They will. We will prove that. This is called motional EMF. This explains Faraday's law.
So how do you determine direction of I in the upper one?
Both will be explained. There are 4 ways, 4 procedures. Right now we learn 3. Give me the board. I just need the board.
So, but in the first video, when you told it's FBI, so how do you tell direction of I?
FBI. The rod is moving to the right. All positive charges on the rod are moving to the right.
Got it.
So force is in upward direction. So positive charge accumulates this way, negative charge. Technically, in a solid, positive charge doesn't move. It's the negative charge which is moving down. So indirectly, from a neutral atom, if negative charge goes down, I'm left with positive charge.
So, but why did force act only on positive charge and not on negative charge?
It acts. Ironically, it is the reverse. Force acts only on the negative charge. Because negative charge is moving. Positive charge is fixed to the lattice structures. BLV, conditions apply. All 3 should be mutually perpendicular to each. BLV, conditions apply. All 3 should be mutually perpendicular to each other. Don't forget that. What if they are not perpendicular? Resolve them such that they are mutually perpendicular to each other. One second, wait.
Done, sir.
Justify that this explains Faraday's law. I will justify after telling you how to decide the direction of the induced current. Motional EMF में induced current. You have a magnetic field this way. This is R. This is moving with a velocity. First procedure, see the alignment of positive and negative charge. The upper part is positive, lower part is negative. So I take BLV this way and this will be the direction of current BLV by R. This is the first procedure. Direction of induced current. Direction of induced current. This is the first procedure, which is quite obvious, right? Second procedure. Lenz's law. Listen carefully. 1 second. Now you will know why BIL exists at the first place. BIL, current carrying wire in a magnetic field, has a force on it. How much?
BIL.
BIL, right? Now, when I give this slider, these are two thick rail tracks on which the slider is given a velocity v. Suppose Lenz's law didn't exist, I gave this a velocity v on smooth rail tracks, and this of length L is continuously moving with uniform velocity. It is producing current without doing any work. And nature doesn't like that. Nature doesn't like that. Like what?
Change in flux.
Producing current without doing work. Right? I gave a velocity v and it is sliding with uniform velocity. So there is induced EMF and it produces current without doing any work. Nature doesn't like that. So what does nature do? It opposes the cause. This is a thin rod. You gave a velocity v in this direction. Current carrying wire will exert, magnetic field will exert a force of BIL on a current carrying wire. So I know the direction of BIL should be opposing the velocity. BIL must oppose the velocity. Why? It should oppose the cause. If it doesn't oppose, what will happen? The slider will be moving with uniform velocity. Slider will be moving with uniform velocity and that will be producing current.
But
It must act in the backward direction. Firstly, it should exist. Secondly, it should act in the backward direction. If BIL should be in backward direction, FBI, B is inwards, force towards the left. Middle finger is the induced current. So induced current is from P to Q. So this is one way of deciding the direction of induced current. This is the second way of deciding. This will be 90% of cases we will use this. Somebody was saying something.
so, but earlier you commented that it won't be an equal and opposite force, right? Some force less than it to stop it. So why it is equal to BIL? Shouldn't it be some value less than BIL?
How much force are you applying? We didn't speak of. That force should be equal to BIL, maybe greater than BIL, lesser than BIL. That decides the acceleration, deceleration, or uniform velocity of this.
Right.
Right? We didn't touch that concept of how much force I'm applying. Maybe it is equal, maybe it will be lesser.
I'm asking that backward direction wise BIL active.
डायरेक्शन पूछ रहे हो या मैग्नीट्यूड पूछ रहे हो?
Magnitude.
मैग्नीट्यूड तो BI ले रही है. Current is I. So the force on the current carrying wire is BIL, I into L cross B. Now you understand the reason why there should be BIL at the first place.
Yes, sir.
If BIL didn't exist, the wire would be moving with uniform speed, producing current without doing any work. Because BIL exists, the wire will be slowing down. Whatever velocity you gave was the initial energy, which will come as impulsive current. Right? There is a third procedure as well for this. What is the third procedure? Take down both of them and go to the third procedure.
Done, sir.
Third procedure is understanding from Faraday's law. You have a magnetic field this way, and this is moving to the right. Area intercepted by the magnetic field is increasing, yes or no? Area is increasing, implies the flux is increasing. Increasing flux must be opposed. Do you agree with this?
Yes, sir.
To oppose the increasing flux, you should have current in such a way such that it is opposite to the direction of the magnetic field. Induced current is in anti-clockwise direction. Anti-clockwise direction, in this case, to oppose the increasing flux. Now, magnetic field is inverse. If I have induced current in anti-clockwise, it will produce a magnetic field outwards, which will oppose the increasing flux. Do you agree with that?
Yes, sir.
Take it down till here. That's the fourth way of finding out the direction.
Done, sir.
Fourth way of deciding the direction is Fleming's right hand. Up to you are using only Fleming's left hand. Force on a charged particle and a current carrying wire. Fleming's right hand rule, VBI. VBI. Left hand rule it was FBI. Replace force with velocity, magnetic field, current, VBI. Thumb represents the velocity, forefinger represents the magnetic field, middle finger the induced current. Fleming's right hand rule. Thumb represents the force. Forefinger represents the magnetic field. Sorry, thumb represents the velocity here. BB, middle finger, direction of induced current. VBI. VBI. This will be the direction of the induced current P to Q. 4 procedures. Most used will be either Lenz's law or Fleming's right hand. Bolo.
How did right hand thumb rule give us the answer?
Velocity, magnetic field,
No,
induced
not how
current,
did you apply it,
and the
but
direction of induced current.
why did that rule give us the right answer? मतलब ऐसे right hand rule उठा के you told कि
1 second,
answer.
wait. There is. बोलो फिर से बोलो.
So I was saying that how did you see that right hand thumb rule will give us the correct answer? Like you just picked up right hand thumb rule and said that it is following it, but why is it following it?
You want to know why it works?
Yes, sir.
The observation they have summarized it this way.
Okay, sir.
They know current goes in this way, so they summarize it as VBI.
Understood.
Right? VBI. Velocity, magnetic field, induced current. This will be the direction in which I've got induced current.
Answer in the area analogy, only the it is not a filled thing, right? It will just be a periphery is increasing. So how was the flux increasing?
As this rod is moving to the right, area of the magnetic field intercepted by this rectangular loop is increasing.
So but there's nothing in between. It's just a border wire like.
This area is increasing or not?
Yes, sir.
That's what.
Okay, sir.
P dot A.
Done, sir.
Now that we know the direction of induced current, let us justify that motional EMF is explaining Faraday's law for us. This is a rectangular loop which is moving into a magnetic field. This is of length L. Before I come to this, if a thin rod is moving with a velocity v this way, parallel to the length, what is the motional EMF across the rod? 0. V should be perpendicular to L. What if the thin rod is moving with a velocity v like this? This will be v cos theta and this will be v sin theta. This is L. Motional EMF will be VL v cos theta. V sin theta will not give me any motional EMF. So whenever a rod is moving parallel to its length, there will be no motional EMF. Why have you explained this at this stage? Observe this rectangular loop moving inside a magnetic field of length L moving with a velocity v of breadth b. What will be the motional EMF for this loop which is outside the magnetic field? 0. Motional EMF for this length which is outside the magnetic field, 0. Yes or no?
Yes, sir.
Now
Yes.
this length is moving parallel to its length. What will be the motional EMF for this?
0. 0.
Only for this I will have a motional EMF of BLV and the current will become BLV by R. Anti-clockwise direction. Resistance, all the 4 loops ka resistance I added and I put it here. All the 4 loops ka resistance I have added and I have put it here. Right? Now you used what? Motional EMF. Agreed? Kindly use Faraday's law and get the same answer. I will believe that motional EMF explains Faraday's law. Now in Faraday's law, if I take this length to be x, E is equal to d phi by dt. Do you agree with that? D by dt of B dot A. D by dt of B, A will be L into x. Agreed? This turns out to be BL into dx by dt. BLV. So induced EMF, even by Faraday's law, you are getting the same thing. Current will be BLV divided by R. Current will be BLV divided by R. Right? So justification for Faraday's law explained by motional EMF. 1 second. Somebody said, can you name the 4th way again? Where is opposite to velocity method, area method? First rule for direction of current was when the slider is moving, this is positive and this is negative charge. When the slider is moving, positive charge is accumulated here, negative is accumulated here. Hence, I get positive and negative. That was the first rule. Second rule we said was BIL should be opposing the velocity. So FBI, Fleming's left-hand rule. Third rule we said, as the area is increasing, the magnetic flux is increasing. Magnetic flux is increasing. Increasing magnetic flux should be opposed by producing magnetic field opposite to the external field. So current should be in anti-clockwise direction. Fourth rule, Fleming's right-hand rule, VBI. How did you accumulate charge that way? When the rod was moving, motional EMF, when we started, first thing, have a look at your notes. Motional EMF, when we started, there was accumulation of positive and negative. First thing, BLV, how did you derive? This was positive and negative. Force on this was BQV and DQ. Have you written this? EMF was E into L. You wrote BLV. There was accumulation of positive and negative. Yes,
Yes,
or no?
sir.
Are you a spammer? Why was positive on the top? क्या मतलब है यार? कोई spammer होगा?
What is the name?
First thing that we dealt with in motional EMF, do you have it in your notes? FBI. Why will positive charge go above means what do I explain to you? Negative charge goes downwards. Right? So from a neutral body, negative charge, FBI, when a rod is moving this way, FBI, force on the positive charge is upwards, right? So positive charge will accumulate here and negative charge will accumulate here. FBI, yes or no? Take it down, take it. Tell me when I can rub the board. What if the loop is completely inside the magnetic field and it is moving with a velocity v?
0.
Two ways. Suppose I deal with motional EMF. This will be one battery, this will be one battery. This is BLV, this is BLV, this is R. Induced EMF will be 0, induced current will be 0. Great. Suppose I deal with using Faraday's law. D by dt of flux will be induced EMF. Flux is B dot A. B is constant, area is constant. So induced EMF will become 0. We are justifying Faraday's law in more than one way. So motional EMF is explaining Faraday's law. What if the loop is coming out of the magnetic field? What if the loop is coming out of the magnetic field? This part is outside the magnetic field. What will be the motional EMF? 0.
Yes.
This part is moving parallel to its length. Motional EMF in this part will be
0.
motional EMF in this will be
0.
all 4 wires ka resistance I have put up here and this will be BLV. How did you decide this BLV? This is moving to the right with the velocity. Fleming's right hand rule, VBI, VBI. Middle finger gives the direction of induced current. Induced current, and hence it's this way. Right? Induced current will be BLV by R. What if I want to use Faraday's law? Faraday's law. E is equal to d phi by dt. B L dx by dt. This length I take it as x. Dx by dt will be V. Faraday's law also gives me BLV, obviously with a negative sign, because when it was entering, if it is positive, when it is going out, it will be negative. Induced current will be in clockwise direction here. When it was entering, it was in anti-clockwise. Here, induced current will come in clockwise direction. Using Faraday's law, how do you want me to get direction? Observe this carefully. Loop is going out. loop is going up. Area of the loop intercepted by the magnetic field is decreasing. Yes or no?
Yes.
So magnetic flux is
Decreasing.
to oppose the decrease, you should produce a magnetic field in the same direction.
Yes, sir.
To oppose the decrease, you should produce magnetic field in
Same direction.
Same direction means you need magnetic field in this direction. That happens only if the current is in clockwise direction. Summarize what we have done. First, Faraday observed certain facts. What was his observation? Rate of change of magnetic flux was equal to the induced EMF, right? Rate of change of magnetic flux was equal to the induced EMF. So whenever there is a change in magnetic flux, there is an induced EMF. Whenever there is change in magnetic flux, there is induced
EMF.
EMF. Right?
Yes, sir.
I'm expecting a question from you people. थिन रॉड जब मूव कर रहे हैं यार, इसका कुछ एरिया होता है? थिन रॉड जब मूव कर रहा है, फ्लक्स तो डिफाइन नहीं होगा. The area swept by it आप ले रहे हो. The area swept by it ले रहे हो आप. Because that coincides with the rectangular loop. But technically thin rod का कुछ एरिया है?
No, sir.
So there is no flux. So there should be no induced EMF. इसके लिए मैंने legality of the statement बताया. Whenever there is change in flux, there will be induced EMF. Faraday सही बोला है. Reverse के बारे में कभी कुछ नहीं बोला उसने. He never told you there will be induced EMF. Whenever there is induced EMF, it should be only because of change in flux. ऐसा थोड़ी बोला है. भाई साहब, when there is a thin rod moving, polarization of the charge happens. That is motional EMF. It explains Faraday's EMF is a different issue. Faraday was not a scientist. He observed a fact and he summarized it. He never tried to justify why things are happening that way. And his fact was an awesome observation, which changed the course of physics. Right? We are not undermining Faraday's contribution to physics. It is unparalleled. But he told you whenever there is a change in flux, there must be induced EMF. Whenever there is induced EMF, it should be only because of a change in flux. ऐसा थोड़ी बोला हुआ है, नहीं बोला है उसने. Right? Motional EMF, polarization of positive and negative happens. Right? So his law is an observation. Whenever this is happening, that's happening. Right? Whenever there is change in flux, there will be induced EMF. Whenever there is induced EMF, it need not be only because of
Change in
Change in flux.
right. Second, we learned how to decide the direction of the induced EMF. Direction of induced EMF. 1. See the polarization of charges. 2. Use Lenz's law. Oppose the cause. If this wire is moving to the right, there should be BIL to the left. So FBI, F should be to the left, magnetic field is inwards. So current should be in the upward direction in this branch. Or area is decreasing. Lenz's law can be applied in two ways. Here area is decreasing. Decreasing area should be contributing to decrease in magnetic flux. How do you oppose the decrease? By producing magnetic field in the same direction. So induced current should be in clockwise direction. Fourth procedure, Fleming's right hand rule. VBI. VBI. Fleming's right hand rule. Velocity, magnetic field, induced current. Velocity, magnetic field, induced current. Is this clear till here?
Yes, sir.
There are many intricacies involved in this technique. For example, the statement which I just now told you. We will continue with those intricacies in the next class. Today I will have to take up current electricity exercise 3 cutouts. We are left with that small part. We thought last half an hour every class will take little of a bit and finish it up. Right? So we stop electromagnetism here. We'll open current electricity. 1 second, Rupo. This
So
second.
last class you had mentioned that you were teaching in the first 10 minutes of the doubt lecture. Which class was that?
So you told that you had taught something important to see in that out class.
You'd asked us what's the recording.
Yes, sir. You were telling us about electrical fields and magnetic fields with relative frames.
Relative length.
Okay. That also needs to be explained. So no, that is important. Can I rub the board?
Yes, sir. You are taking that now?
Yeah. 5 minutes I deal with that and at least one para I clear from current electricity. Exercise 3. Now listen. This is a current carrying wire. There is an observer here. Right? Name this observer. Give him some name.
A.
Park. Right? All of the class is asking Park, do you have a magnetic field here or electric field? Parth will reply, I don't have a point charge with me. Give me a point charge. I'll tell you if there is an electric field or magnetic field. So then we decide to give him a charge. He keeps the charge at rest and the charge remains at rest. So what will immediately Parth say? Electric field is zero. Do you agree with that? Do you agree with Parth?
Yes, sir.
Electric field is zero. Charged particle at rest continues to be at rest. It will remain at zero. Right? Electric field is zero. Now we ask Parth, do you have a magnetic field? Parth will say, till you give the charged particle a velocity, I cannot speak about it. Fair enough? Right? Then we give this particle a velocity v upwards. Because of the current carrying wire, magnetic field is inwards. Now FBI, force is towards the left, particle turns this way. What will Parth immediately say?
There is a magnetic field.
Magnetic field is not zero. This is Parth's observation about electric and magnetic field in this particular region. Now there is a second observer here. Name a second observer.
Ramu Kaka.
We had one guy who had a DP remove JE and save India.
Arvinder.
Arvinger.
Harbinger. Harbinger. Now Harbinger is moving with a velocity v parallel to this target part. What is Harbinger doing? He is moving with a velocity v parallel to this. Now, according to Harbinger, this charged particle is accelerating straight towards the y. Is accelerating straight towards the y, and its speed is increasing in this direction, and it's going straight. So he will tell us that electric field is not zero, magnetic field may be zero because the particle is going straight towards this one. Harbinger is moving with the same speed as that of the particle. So at that instant, he will see the particle accelerating towards the y, straight towards the y. So Harbinger will report magnetic field to be zero, but not electric field. Magnetic field may be zero. हो सकता है magnetic field is there in the same direction. May be zero, but electric field for sure he will say is not zero. What have we learned from this? From two different frames, you are reporting two different fields. What actually exists is electromagnetic field. What actually exists is an electromagnetic field. From some frames, I will see an electric field. From some frames, I will see a magnetic field. Some frames, I will see an electric field. Some frames, I will see a magnetic field. From some frames, I will see electromagnetic field. Pure electric field, pure magnetic field are a myth. Which observer do you want to say is the actually true observer? Both are equally true. What you measure is the quantity given. You cannot tell me that his answers are more appropriate because I am observing from ground. Why should you observe from ground? What is wrong in this observer? It is more like telling you absolute motion is never defined. Sitting inside a train, if I tell you the trees are moving in the backward direction, my statement is right. Sitting inside a train, I will tell you the trees and buildings are moving in the backward direction. Statement is right. You cannot deny. Only thing I did not complete my statement. I am describing the motion of the tree with respect to the train. Sun is going around the earth. Statement is right. I am describing the motion of sun with respect to earth. Absolute motion is never defined till you tell me the frame from which you are observing. Same here. Electric field. Arey nahi yaar, magnetic field. Arey nahi yaar, electromagnetic field. All three of them are right from their respective frames. Are you trying to suggest that nature has a mysterious way of using electric and magnetic fields to its convenience? Yes. क्या बोल रहे हो? What exists is electromagnetic field. What actually exists there? Nobody knows. Which frame are you observing from? I am observing from some frame. Then your answer is right. You are observing from some other frame. Your answer is right. Who is more appropriate is a meaningless question. I'll give you one more example. बड़ा ध्यान से सुनिए. F is equal to Q into E plus V cross. Somebody asked me in your batch only, why should it be given the significance of a Lorentz force? Now you'll understand the significance. You have a charged particle inside this magnetic field moving with a velocity. Once again, path is at rest. Path is at
Rest.
Ask him what is the force acting on it. What will Parks say? Q into E. Sorry, Q into V cross B. Q into V cross B. This is path comes. Path is at rest. Right? Let us take one more student. Name one more student. Chinmay. Chinmay is moving with a velocity v same as that of this particle. But ध्यान से सुनिए. Chinmay is moving with a velocity v same as that of this particle. According to Chinmay, velocity of the particle is
0.
According to Chinmay, the particle is at
Rest.
Force due to magnetic field on the particle should be
0.
0, right?
Yes.
Yes, sir.
Yes or no?
Yes,
Yes.
sir.
But Newtonian mechanics doesn't accept that both of them are inertial frames. From two inertial frames, you report a force, it should be the same. This observer is at rest, this observer is moving with uniform velocity. So Chinmay will report Q into E, and he will report both of them equal. Both will be equal. Both will be equal. ये electric field कहाँ से आ गया यार तेरे लिए? This observer, when he is moving with a velocity v, he will see only an electric field and not a magnetic field. What actually exists is an electromagnetic field. From some frames, I will see an electric field. From some frames, I will see a magnetic field. From some frames, I will see electromagnetic field. Suppose there is a third observer, ACP, moving with a velocity v dash. Not the same velocity as the others. But he is also on an inertial frame. All three are on inertial frames. All three should report the same force on the charged particle. They will report the same force on the charged particle. ACP will observe both electric and magnetic fields. He will report Q into E dash plus Q into V dash minus V. V dash minus V cross B. And he will also tell you this value will be the same. All three will report the same value. This observer will report only magnetic field. This observer will report only electric field. This observer will report both electric and magnetic field. What actually exists is an electromagnetic field. How does this transformation happen? Electric fields, a magnetic fields, electromagnetic field. This transformation happens in a very subtle way. The explanation is very beautiful and requires a lot of energy. It is not required for you for JE. So once the syllabus is over, I'll explain that. Exact explanation is properly given only in Purcell. PURCELL. Right? PURCELL. Electricity and Magnetism by Purcell. Berkeley series publication. Right? That is actually beyond the scope of your syllabus, but a very beautiful application. This is something that you should know. You have objectives based on this concept both in your booklet and one or two reasoning questions of Excel. This consumes too much of energy. This chapter as it is heavy concept.
So in first one, why did I say that V is not equal to 0 and E is 0?
The particle was at rest initially.
Yes, sir.
So particle at rest is not deflected, means electric field is 0.
Yes, sir.
And when you gave a velocity, it suddenly got deflected. Implies magnetic field is not 0.
So at that time, why is electric also not 0? It was moving.
First particle is kept at rest. You first confirmed.
Yes, sir.
So then you concluded electric field is zero. Particle was getting deflected only when it has got a velocity. That means it's only because of magnet.
Understood, sir.
Harbinger is not there in the classes, right?
Doesn't seem like.
Yeah, his TP is missing. Gaurav has tried comprehension 7 question number 30. Here it's tiring. Here I'll take it up in the next class. I first thought I'll deal with this. Exercise 3 current electricity next class में लूंगा. Okay.
Sure, sir.
चलो. Wish you all a happy weekend.
Thank you, sir.
Thank you, sir.
Good day. Bye.
Bye, sir.
Thank you, sir.